Okay, day 3, absolute value equations and inequalities. With absolute value equations, be sure to isolate absolute value first. So if I were doing the first one here, I would subtract 2, divide by that -1, and then I would, once I have the absolute value isolated, what's going to happen? So basically, I know that this thing inside the absolute value bars, this x plus 3, could either be 8 or -8, right? I know if I take the absolute value of 8, it's 8. If I take the absolute value of -8, it's 8. So that x plus 3 could be an 8 or it could be a -8. So x plus 3 could be 8 or it could be -8. And that's it. Since the domain of an absolute value is all reals, we know we don't have to reject anything. It's not a bad idea to check, just like if you're ever unsure, if you've done it right, then you could check those answers to see if it works. Divide by a -1. Now here the 3 is not under the absolute value, the 3 that's in the denominator. So I still have not isolated the absolute value. I want to multiply by 3, and then that way I have that. So now 3 minus 2x could be equal to 3, or 3 minus 2x could be equal to -3. X is 0. Or x is 3. Now, when we have two sets of absolute value bars, I can take the one on the left, and I'm basically going to set it equal to the positive, like exactly what's on the inside of the other one. And then I'm going to also set it equal to the negation of what's on the inside of the other one. And then from there, I can just solve. X is 3. And x is -3. All right, so this one I would have 5 halves minus x equals 2 minus x over 2, or that maybe I'll put it down here, or that 5 halves minus x would be equal to the negation, -2 plus x over 2. Now, for solving something like this, what I would probably do, because I don't want to deal with fractions, I would multiply everything by 2. That will get rid of the fractions. And then I can just add the 2x and then minus the 4 and x is 1. I could come down here, do the same thing, times 2, everything times 2 to get the denominator out of there. And then, let's see, add 2x, 9 equals 3x, x is 3. So those would be my two answers there. Now, when we're doing absolute value inequalities, we still want to make sure we get the absolute value isolated first. Now, they say if it's greater than or equal to, you're going to set up the first inequality as you see it. The second, you're going to flip the inequality sign and negate the number. If it's less than or equal to, you're still going to get it isolated, the absolute value isolated first. And then we do something where we call sandwiching it in between the plus and minus on the other side of the inequality. Then we're going to write our answer using interval notation. Okay, so let's see. This is less than. So less than or equal to, that's right here. We are going to use the sandwiching method. But first, remember, we have to isolate the absolute value. So here's what I mean by sandwiching it. The 2x minus 4, we're going to keep it less than 5. It's going to be greater than the negative 5. So that 2x minus 4 gets sandwiched in the middle of negative 5 and 5. And then what happens is it's like you're solving two equations, or two inequalities, I should say, not equations. They're inequalities. We're solving two inequalities at the same time. So if I'm adding 4 to the middle, I have to add 4 on either side of the inequality. This is negative 1, less than 2x, less than 9. And then I would have to divide by 2. Now, part of the reason you want to do this is you want to realize this is an and. Whenever it's, the x is sandwiched in the middle, that's an and. So you want what would satisfy both of those, which is just from negative a half to 9/2. Oops, sorry, not hard brackets, soft brackets, because it's not equal to. Here, add 6. So doesn't matter which type it is. First step is always to isolate the absolute value. Okay. Then when I get to this step, this is greater than or equal to. So greater than or equal to, you take the thing inside the absolute value. You're going to take it out of the absolute value bars, set it greater than or equal to 12, or it could be less than or equal to negative 12. So that's what they're talking about. Flip the sign and negate the number. That's what I'm talking about right there. We flipped the inequality sign. We negated the number on the right of the equation. So now you just solve these each individually. Okay, divide by negative 2. Now what you have to remember with an inequality, when you divide by a negative, you flip the inequality sign. So same thing here. I'm going to divide by a negative 2, so I have to flip the inequality sign. If I write my answers in interval notation, sometimes it helps people before they write an interval notation to visualize on a number line. So if I say less than or equal to negative 9/2, that would look like this. 15 halves is somewhere over here. Greater than or equal to 15 halves would look like that. So it'd be negative infinity to negative 9 halves, hard bracket, u 15 halves to infinity. And again, hard bracket. Here I'm going to add 15. Divide by 2. Okay, it's greater than, so 5 minus 2x is going to be greater than 10. So I take that out of the absolute value. I keep it greater than 10. 5 minus 2x out of the absolute value would be less than negative 10. So I'm flipping the sign and then negating. Divide by negative 2. If I divide by a negative, I have to flip my inequality sign. Okay, so again, you could visualize it on a number line, but your answer will be negative infinity to negative 5 halves, and then 15 halves to infinity. So what you're going to notice, greater than or equal to, those are or, they're joined by or. So that's why you get two different inequalities, like two different interval notations with the u in the middle. What you're going to know with less than, like example 5 here, or like example 8, less than or equal to. Less than or equal to, it's going to be sandwiched in the middle because it's an and. If I was joining it, it would be with an and symbol, but it ends up just being in the middle, like there's overlap to the two inequalities. So divide by 4. Okay, so I take the 3x minus 5, less than or equal to 2. It's greater than or equal to negative 2. So it's sandwiched in the middle of the negative 2 and the 2. And then I solve, add 5. It's like I'm solving two inequalities at the same time. Divide by 3. 1 is less than or equal to x, which is less than or equal to 7/3. So what I'll see in interval notation, there's just one interval. So for less than, or equal to, there will always just be one interval for your answer. Greater than or equal to, there's going to be the two intervals because it's an or versus less than or equal to, which is an and. Okay, that's it for day 2.